Hello everyone. In this video we are going to learn how to obtain the Fourier transform of periodic signals. The question asks us to find the Fourier transform of this signal. If you pay attention, you can see that this signal is periodic. If I want to give you a definition of a periodic signal is one in which a template of the signal repeats itself over time, from negative infinity to positive infinity. Now, if you look at this figure, you can see that the template I am showing you is repeating. If you look closely, the time interval between the first repetition and the second repetition is 2. Therefore, we consider the period of this signal to be 2. When the period of the signal is 2, the fundamental angular frequency omega 0 is equal to 2p divided by t, which gives us p. So far, we have seen that this is a periodic signal in the time domain. Now, we need to compute its Fourier transform. To calculate the Fourier transform, we will first go over some key points and then we will use those points to obtain the transform. The first point is a signal called the impulse train. This signal is periodic with a period of t, as you can see in this figure. It consists of a set of impulse signals placed next to each other with a period of t. The Fourier series coefficient of this impulse train signal AK equal to 1 divided by t. The second point is that for periodic signals in the time domain, you should first calculate their Fourier series coefficients and then using the summation of two p AK delta omega minus k omega 0 obtain their Fourier transform. The first point is the time shift property of the Fourier transform. Based on this property, if the Fourier transform of the signal x of t is x of j omega, then the Fourier transform of the signal x of t minus t0 will be e to the power of minus j omega t0 multiplied by x of j omega. Now let's move on to solving the given exercise. In the signal systems, the name of the impulse train signal is PAT. If you look at this figure, based on the first point, we can express this signal as the sum of two impulse trains. The first impulse train has a period of 2 and amplitude of 2. And the second impulse train has an amplitude of 1 and also a period of 2. But it is shifted by 1 unit to the left or to the right. Notice that it doesn't start from 0. Instead, it starts from 1 or from -1. Therefore, we can consider it as an impulse train that has been shifted by 1 unit to the left or right, which makes no difference. As a result, we can write this signal as 2 times PT plus P t minus 1. Also, the Fourier series coefficient of the signal P of t are equal to 1 divided by t, which in this case is 1 divided by 2, and omega 0 will be equal to P. Now, based on the second points, the Fourier transform of 2 pt becomes 2 multiplied by the summation of 2p alpha delta omega minus k omega 0. Here alpha is equal to 1 divided by 2 and omega 0 is equal to p. And the Fourier transform of p t minus 1 is the same summation of 2p alpha delta omega minus copy but since we have a time shift with t0 equal to 1 based on the first point, it must be multiplied by e to the power of minus j omega t0, which is e to the power of minus j omega. Finally, the Fourier transform is equal to the sum of these two Fourier transform. If you enjoy this style of video, the next one will also be from the same topic.